So thank you, Todd, for the introduction. Like you said, I'm Omar Al-Abed. I've been with GE for about 10 years now. Redefining product development with 3D scanning and PolyWorks. So let me just start by saying that we've been at this journey for about 2 years now. So it hasn't been very long for us to transform our business to a 3D world. And I'll go through that in the slides to come. But slowly and surely, we started to use PolyWorks and 3D scanning to redefine how we run our business, right? From start to finish, from MPI to first-time builds to all the way to production. And we'll go through some slides that talk through that. And we'll start off by saying who we are as a company. So from those guys who are from here, right, here based like in the US, right, GE Appliances has been around for 125 years, right? Full suite of appliances, everything from dishwashers to refrigerators, stoves, water heaters, etc. I'm sure you guys are very familiar with that kind of stuff. So based in Louisville, Kentucky, we have 6,000 employees based in Louisville, 12,000 across the world. So with the recent transition with High Air, which makes us the largest manufacturing company in the world now. So slowly through that transition, we're growing at an exceptional rate. And with that, you know, using these new tools, we're showing the business the capability of the tools for one, and also how we can speed up the qualification process and different things to go faster. And with that, we're leveraging our new, I guess, parent company to show how they can transform their business as well. Roughly, you know, just off the top of my head, we make probably about, just out of Louisville, Kentucky, about 4 million units out of there, so appliances. Tack time, roughly about 17 seconds, so we're moving pretty fast, right? No margin for error, so everything we do on the upfront makes things go faster. So, product development journey, right? This is basically a slide that talks about, from start to finish, where we are growing and where we're trying to develop what we're trying to do as a business. So, you know, we partner with a company actually very close to here early on 2 years ago, and we learned a lot of this information on how to do, you know, CAD-based inspection, use GD&T, 3D scanning, and with that company, we leverage our own internal process to say, hey, let's leverage what we learned through automotive and do that in a new realm, which is consumer goods. So some of the stuff you guys probably already do today, but in our consumer goods world, it was new for us. So when we launched into it, we launched full bore, right? I like to think that, you know, prior to this, right, we rarely ever used the CAD model, right? We would do a lot of upfront engineering to create the CAD model, but then we would reverse engineer it back to 2D print, right? So that being said, you know, everything we designed basically just went out the window. So when we learn these new things about, you know, bottoms-up design, you know, global origin, CAD-based inspection, pulling the PMI data off the CAD model into your inspection, whether that's CMM or scanning, et cetera, right? It was such a powerful tool for us. And now it's just off to the races, really. It's very exciting stuff. Especially with what PolyWorks has done with CMM, I mean, it's transformational for us. We're slowly trying to convert all our CMMs to PolyWorks now. It's pretty great. So some applications, right? So most of the stuff we do is part and assembly inspection, right? We come from a world, I would say, that it's, you know, we weren't the metrologists at first, right? That was a focus area that wasn't around. We approached this with an engineering mindset, I like to think, right? So we were engineers first and then brought in this tool. So we're like, okay, we have this new tool, what can't we do with it, right? So of course we have all these part assemblies that we started with, but then, you know, large scale virtual assemblies, which I'll talk about here in a second, using photogrammetry is super powerful. Prototype builds, tooling inspection, right? We were big on, you know, I would say first piecing the tools, but I mean the parts coming off the tools, but very rarely where we first piece the tool itself, right? Scan the tool, archive it, see where we're at each build phase. So whether it be like reverse engineering, CAE, we'll talk about that, and you know, just some case studies on VR and volume, right? So throughout this presentation, I'll kind of touch on each one and where we leverage the technology and also how we use it today. So just jumping right in. Part and assembly inspection, right? So this is a unit door and door, right? So we do a lot of things, digital assembly or virtual assembly, which is big for us, right? So before the product is built, we'll scan each part as it rests on the unit and deconstruct it and scanning at each phase, aligning it to the DRF and seeing where our deviation is, right? So from here, right, as it sit as a full unit, looking at the right-hand door, there is deviation proud, right? You can't see it, but that's probably 2 millimeters. So if you're looking at the unit as a consumer, your flush and gap is awful. So deconstructing and realigning it virtually, we found that after everything, the deviation was coming from the door versus the frame door or the case, which is actually pretty CAD nominal. Talking to it more in detail, right? So what we would do is we would also take each part that we would get, and we would align it as it's set, and we would give feedback directly to the engineers. A tool for us, right, is, we like to think of scanning in PolyWorks, like with the color map, like a giant highlighter, right? It's quick feedback to give the engineers exactly what they need to go fix. So for instance, in foam doors, right, so your door is shot with cyclopentane, which is a foaming agent which expands and grows. So with that, right, if you have any localized deviations, proud or sunk in, that information can then get transformed to the fixture where it gets foamed in, and they can have direct feedback on how to improve the foaming process. So through each phase, we were scanning doors after they go make a change, rescan, and quickly they would know exactly where to go shim it and fix it. Now we're launching with a CAD nominal door, right? So everything is basically built to CAD nominal, and it's pretty much perfect every time. So this is a pretty good example. So this is a linear actuator, right? So it's a gear that travels on a rail, right? And so it would get impinged and would seize up, mostly at the home position. And so what we found was that that the gear actually was getting locked up at the home position because it was proud. So this is in inches, by the way, so 10,000ths. And you can see in the bottom right there that between the CAD and the scan, that it was actually impinged in. So it was seizing up in that position. Now, going back to what I said earlier, 30 years of us using CAD models to maybe design this, but going back to a 2D print, we would first piece, PPAP to our 2D print, which our 2D print wouldn't have even caught this kind of issue. We might have pitch, we might have different things that talk to the gear itself, but the full surface scan, going back to that highlighter thing I was talking about, it was so powerful for us, right? So now we can use our first piece data to say, hey, here's what we need to go improve, and here's what we actually need to do, which was quick feedback to say, hey, this was the issue, let's go back and fix it. We found that in the molding process that it was cooling and causing it to be proud. Just for fun, we actually CT scanned it just to prove it out, the theory that it actually was doing it. So we CT scanned it and saw that it was impinged, and that was the issue. And I would beg to say that our first piece process has now changed our mindset as a business, that we kind of question everything that we are getting from our supplier, right? Prior we get reams of data, you would say, whether it be CMM or just Excel data. Now, we're questioning and saying, is that really accurate? So spot scanning and just doing the quick color map is pretty eye-opening for us. Here's a good example, washer basket runout, right? So it's more like your washing machine is spinning and it has like an out of balance condition, right? It's wobbling and moving. So when it's aligned to the spindle, right, it was causing an out of balance position. You can see how it's proud on one side and you turn around, it's deviate opposite on the other side, right? Data reference frame is super important. Anybody can make data, but can you make the right data set, right? Can you align the data how you need to align it? How can you actually hold it in the right position, right? So that's so important. I just want to stress that. So talking to it, deconstructing it, we actually found that the basket was pretty nominal. And the deviation, right, virtually was coming from the basket bottom itself, right? So you can see how it's kind of proud and tilted. and tracing it back to the tool, right? So that basket bottom is an overmolded steel hub, right? So that steel hub is what you see in the top right there. It's on an overmolded plastic part. And what we found is that when we scanned the hub and we aligned it to the tool, so virtually, right, we pulled the tool in and we aligned the hub in the tool, and as it's set on the tooling pads, right, so called the tooling datum, so the datum reference frame of the tool, we actually found that it was proud, so it was bowed. So after it got overmolded, it captured that warped shape and it deviated all the way back to the full assembly. So that cross section down at the bottom there kind of shows how it's crashing the tooling pads and how it's sitting cockeyed. So virtually we can find out that, hey, we have this issue. Let's not even go to the tool. We can do it from our desks. And now we can say, hey, engineer, adjust your tooling pads and have a level surface every time. So another quick way to solve that issue. This is actually the spindle which the basket sits on. Top of a washing machine, right? It's a transmission that spins the unit, right? The transmission runs through two bearings, and it basically is a Tox press fit full assembly. So the two bearings are actually on the top and bottom. Even before we would actually Tox them, we could align those bearings to where they set in the home position, project an axis through the whole component, and see if they were coaxial or not, right? So we can actually find out if it's going to impinge and torque out, right, as it spins through the assembly. Here's another slide that kind of talks to that. So it's 1 degree that it was like that was actually like just misaligned, right? So that projection feature that PolyWorks has is huge. I'm not sure how you would find this data from a tactile method, right? You'd have to know what to measure. You have to know what to go do. I think we tell engineers we don't know what we don't know, right? So the full surface scan data and doing the virtual assembly is something that we do quite often that is huge for us, right? The bearing tilt is actually something that we aligned after it got toxed. We actually found that it was in the assembly as well. So that's CAD deviation that shows that bearing, how it's tilted, right? So we can go back in the assembly and adjust the tox process to get rid of that impingement of the two bearings. So it's pretty big for us, I would say. Traditionally, we can never find this kind of issue. We would be fighting through processes, and people might take CMM data, they might argue over the data, but there would be no way that we can find this from our past lives, right? Brought this up just to show small parts, right? Doesn't matter like the data set. As we learned earlier, like Universal PolyWorks really is a universal software. With this example, right, we were able to find a dishwasher pump that had failed on life tests. And we had 2 pumps that were side by side, and the engineers wanted to find out what had failed. And after scanning the actual components of it, we found that one of the seals undergo severe compression set. So it failed and leaked through the whole unit. Just a quick example of the power of PolyWorks, really. Clearance and interfaces. This one's huge for us, right? So I store gas compression. Gas compression is really big for us. Guys on automotive could probably talk to it. And virtual assembly with gas compression is really big, especially in our scenario. So if you don't have gasket compression on an icebox store, right, you might have a leak throughout certain areas, right? And what that causes is a frost ball that builds up, and you can't shut it, right? It has that frosty material. So gasket compression on a whole unit is pretty much everything we need on a refrigerator. So what we found was that through virtual assembly, right, the nominal compression where it should be was actually deviated up to where it says. So the power of PolyWorks, right, you're able to do this virtual assembly of all the components in a simple state, deconstruct and scan it at each build phase, and then plot a clearance, right, of how the 2 scans are going from each other and see what the gasket compression is. So the color plot is the gasket compression, right, which is profounding for engineers, right? So virtually we can say, hey, we need more gasket compression, or we need more closure force, or et cetera. Pretty interesting stuff. Range burner clearance. So what happens with range burners is that you have a gas channel clearance from the top and bottom, right? Flame distribution is huge, right? So if you take those two burners and you shift them off, you might have flame goes on one side and flame goes on the other side. So the clearance between the upper and lower halves is critical for the team. You know, just like what I just showed in the last slide, you know, doing the virtual assembly of both of them and plotting the color and showing the clearance between the two is basically measuring flame distribution between the upper and lower halves. So it's measuring the gas channel clearance. Something that before we couldn't really measure, we couldn't really understand how to do, right? We might have some issues, but doing this type of process is really going very well for us, and we're succeeding on launching products like this sooner and faster out to the market, right? Some more case studies, part thickness, right? This is really big for us as well, you know, in any type of like injection molding. We'll learn how to find localized thick or thin areas, which before would have been a long process of a long, you know, maybe several hours, if not days, CMM, or we might take, you know, ultrasonic sensor measurements across the whole part, which is great, but it just takes a long time. Scanning the whole thing and doing a thickness analysis across the whole part, you know, took us an hour. And just like this, you know, back to my comment, it's like a giant highlighter. You can easily see how locally thick or thin the part is, which is awesome for a plastics team to understand if they have a tooling condition, right? Just another quick example of PolyWorks, right? Volume analysis. Take the two scans and just measure the volume between the two. We haven't done much here, but you know, great capability there, right? Reverse engineering. Again, like PolyWorks is great for metrology. We didn't start this being metrologists, right? We found this as an engineering tool. Really, we like to think about it as like full surface CAD, right? Or full circle CAD, excuse me. So taking the CAD and seeing what you actually have and comparing it back to CAD. And that's what we're doing here, right? Is taking these scans and turning them back into CAD models, right? So the first one is just taking a scan of the STL of this shroud and then converting into CAD, right? Because a lot of times with, you know, our suppliers, we don't have CAD data. So we'll reverse engineer it to get the CAD for ourselves. Something that it's going to be awesome when we do get 2018. Going from modeler to inspect is going to be huge for us, actually. So we're actually pretty excited about that. The far right one, right? So this is actually a competitor's part. Oddly enough, right, a lot of our labs, we were really big on 3D printing. So we have about 18 printers in Louisville. So actually one of our biggest labs is actually right next to the printing lab. So they're a great relationship, right? So, you know, what we're going to do here is take a competitor's part, and the engineer, it's actually a gas chamber. The engineer wanted to see how it works, so we just print it in clear polymer, and the engineer could see how it worked and how it functioned. Again, a competitor's part thickness analysis, right? The IDO team swore that this competitor's part had zero draft, right? It was a plastic bin that goes in your like unit, like refrigerator, and swore up and down. And you know, we're thinking, there's no way, right? Plastic part has to have draft to it, right? So we went ahead, we took it, we scanned it. That left photo basically is a thickness analysis that what you can see is they did a styling line, right? So they had a localized thick area, so it looks like it's, as it's dead on, it's pretty square to grid. But we extracted the angles and like fit planes to it, so we can actually measure the draft angle from it and say, here's how they did it, right? Simulation, right? This is a really big focus area for us. It's mold flow. So, you know, again, right, it's just taking the data and using PolyWorks to understand what can't you do with the data, right? You know, you almost like to think of it as like a Swiss Army knife. You can just do anything with it. As long as it's data, you can do something with it. So Autodesk, right, has a software called, so that's a mold flow software that is a branch from Autodesk. And what it is it outputs a predicted shape, right? So you say, hey, I'm using this type of press, I'm using this type of material, here's my cooling, here's my tool, here's my CAD part. Even before I cut anything, right, cut tool, here's what I have. But the issue with our company is that sometimes we're not very confident to cut on a brand new tool or cut windage to expect for shrinkage, for warpage. So what we're doing now is validating our mold flow, seeing how accurate is it, can we trust it, can we take it one step further. So we're taking that predicted shape from the mold flow, taking actual scans of it, and comparing the two, right? So you can see in this one, right, they're not too accurate, right? There's some deviation there. It's saying that, here's what we predicted, but here's what we're actually making. Let's compare that to and see what we're actually getting. Diving into one deeper, right? Our mold flow guys are actually here today. They did this with the PolyWorks team probably about a month ago, I'd say. So the dotted lines are different scans of the actual part. And the other ones, there's basically different outputs from the mold flow, right? So it's taking the mold flow output and saying what type of a mold flow mesh is closely with our process, right? So when we go one step further and say, let's try this for real, let's use this type of mold flow output mesh to compare to now we feel confident to cut windage. Taking it one step further, right? That predicted shape, you can take that predicted shape, what we're doing is we're actually pulling it into our inspect. So let's create an inspection plan off of a predicted shape. So virtually, before we even go anywhere, let's see how our tolerance are, how our shrinkage, how our flatness is, how our warpage is. So we can do that before we even go anywhere, right? Before we even cut tool. It's pretty powerful stuff for us, right? Quick example, the team wanted to run CFD on this is a room air conditioner. We didn't have CAD for it, right? Scanned it, pulled in a modeler and turned it to CAD and then ran CFD on it. Tooling and equipment, right? PolyWorks, like again, a universal software takes different data sets, right? We're coupling a photogrammetry system and we're from GOM actually, and then we're actually using the Creaform system for scanning, and we took it one step further and did a focused area scan, all in the same workspace. What that looks like is sounds pretty crazy, but it's about 4,000 targets, right? So it's a lot of stickers, about 12 tri-top sessions, taking that data, pulling it all in, and then using the handy scan to figure out certain features that we care about, and then taking the whole press and using the focused Faro area scanner and then capturing the whole press shape. A tracker would make pretty light work of this now, but we didn't have that tool at the time, but it's just showing how the software just takes data sets from anywhere and combines it together, and you can tie it all and get valuable information from it, right? Just a quick example of tooling clearance virtually, right? Checking upper and lower between two die sections. We're getting really big on golden sampling, right? Let's archive that part away, whether it's part or tool, so we can pull that back up. We can measure tooling wear, we can measure part wear, we can find issues down the line if there's things. So we're actually tying it to the CAD part rev, so it's archived. It's pretty good for us. VR, we're starting to dabble in that a lot. The request came in, right, to the VR team, all right, our craftsmanship team wanted to see our competitor's unit in the same space. So of course we don't have CAD for it, but no problem there, right? We just scanned it, right? NURB surfaced it and then put it in the VR space. So it's the exact same unit. So the craftsmanship team can put on the goggles, and this is a Samsung one. This is a Whirlpool one. So we can actually take that scans and convert it into a pretty good CAD model through Modeler and actually VR render it and take it through it, and actually the team can go on and see different competitors side by side by side. So it's pretty powerful for us. I know automotive guys may have been doing it for a while, but we're pretty excited. Another example, right? So when you put the VR goggles on, if you don't know, you hold a fly stick that does certain things, right? Turns on certain features, opens certain doors. The fly stick itself wasn't in the software, right? So when you put in the goggles, you didn't see the fly stick around. So they asked us, hey, could you scan this and put it in there? We're like, yep, no problem, right? So we scanned it and we converted it back to a CAD model and put it in the VR space. So I think that we like to say if you can digitize it, then what can't you do with it, right? So that's what we're slowly learning. And with this, we're able to root cause, find problems, and really just go faster.